NASA today announced that they had discovered a new network of planets. Maybe you could explain a little bit more about this discovery and why everybody is so excited about it.
You have to realize, Tracy, when you have a planet that you're looking out at around another solar system, we've been looking at these for years, and we've found thousands and thousands of them. And what we found are that Earth-sized planets are actually pretty rare. Most of the planets that we find are 2, 4, 10, 20 times the mass of Earth. In fact, our solar system only has 2 that are about Earth-sized. We have us and we have Venus, and that's pretty much it. And yet, if we look at this system, we found 7 planets around it, and all 7 of them are Earth-sized. So that in and of itself is remarkable. Then if we look at which of these planets have the right conditions for liquid water on their surface based on their distance from the star, usually we're lucky if you can get one rocky planet at that distance. We've got 3 in this solar system, and that's a record, that we have 3 Earth-like planets at the right distance from the star that they can have liquid water on their surface. This has never happened before. So if you were excited when we found that the closest star to us had 1 Earth-like planet that was potentially habitable, yeah, that's exciting. 3 times that level of excitement.
So what does it take for a planet to be able to sustain life? Give us a little bit of a rundown.
So there are a few things that we know we need in order to have life like ours, right? Chemical, carbon-based life that works the way we know life to work. You have to be, basically you need an ocean, you need sunlight, and you need the star to be stable for a long time, right? If you have no ocean, no liquid water, we don't know how life works without it. There may be ways to do it, but we don't know about any of them. If you have a star, if a planet is totally frozen or totally scorched, right? If it's too hot or too cold, no, you can't have it. That's why we call the planets in the habitable-like zones, we call them Goldilocks planets, because they're not too hot, they're not too cold, they're just right, and don't get eaten by 3 bears. And then you have to go and look at, well, do I have the right atmosphere to actually have a liquid ocean on my surface? That's something we can't measure, but around an Earth-like world, we think that's likely. These 3 planets that are potentially inhabited, that potentially have life on them, they're interesting in a way that Earth never will be. We rotate on our axis as we go around the sun. These worlds are locked. Like we always see one face of the moon, these planets, the same side always faces the sun. And so what we should have is, if we have the right atmosphere on this world, and if we have oceans or lakes or liquid water in a stable state on these surfaces, then we could have around a star like this, which we think is even older than our sun, we have had billions and billions of years of sunlight shining on this ocean, incubating whatever life possibly could arise there. So who knows what we'll find? We've got 3 different worlds where this has a legitimate chance of having already happened.
So what do we do from here? It's not like we can just hop on over and take a look. How do we find out?
Well, the good news is we have a number of proposed missions, telescopes, and other ways to observe these planets indirectly or possibly even directly. One thing we're doing is right now the biggest telescopes, including the ones we're using from the ground to look at these worlds, to look at the sun, they're only about 10 or 11 meters across. But we're building telescopes now that are 25, 30, even 39 meters across. And so we're gathering much, much more light. If you put a little, what's called a coronagraph, that's basically like putting up a little disc to block out the star, we might be able to image some of those planets directly. We're also launching space telescopes, like James Webb Space Telescope, WFIRST, and we might even launch a special kind of stellar occulter called a star shade, which would block out at a great distance the light from the star and allow us to directly image the planets behind it. So we have a chance to do direct imaging, to look at the atmosphere, to find out, is there oxygen, is there methane, is there water vapor? Are there the signs of the molecules that we know go along with life? And if the answer is yes, we might just have discovered the systems that give us the first life outside of our solar system. We don't have that proof yet, but unlike any other solar system before, we've got 3 legitimate possibilities for Earth-like worlds.
All right, now you're making me feel very impatient. I want to know, how soon will we begin getting a closer look?
Well, I would say the soonest we can get a closer look is going to come when these giant ground-based telescopes come online. So the next decade is when it's going to happen. The next decade is when this magic's going to happen. The Giant Magellan telescope is going to be the first one online. That's going to happen in the early 2020s. WFIRST, which is a space telescope, which may launch with a star shape, is slated to launch in 2024. And the ultimate near-term hope might be to get that star shade up there even in advance. That would require extra NASA funding and the approval of a mission like this. But if we decide, hey, we need to image these worlds, we need to find out if they are potential candidates for life, then maybe we'll actually get the will to make this happen.
It is a great time to be an astrophysicist, and we thank you so much for sharing your time with us.
Well, thank you. It's my pleasure, and I'll say every time it's a great time to be an astrophysicist.
All right. Thank you so much.